The Fano Gem is a twisty puzzle that I designed to showcase the symmetries of the Fano Plane, which is a familiar object in combinatorics, coding theory, and algebra. It's constructed from 7 points and 7 lines, where each line contains 3 points. If you hold the puzzle red side up, the numbers on the corners match up with the numbers on the plane. There's 1, 2, 3 on the left edge, 4, 5, 6 on the right corner, and 7 is on the back out of view. There are 2 possible moves on the puzzle with different gearing. These moves, which I'll call A and B, perform dual 3 cycles of the numbers, which can be combined to scramble the puzzle and explore the symmetries of the Fano Plane. The Fano Plane is a projective plane, so these aren't just ordinary Euclidean line segments. Just like the circle in the center of the plane, a projective line wraps back around on itself. You can see in this animated version of moves A and B that moving the points around temporarily jumbles up the lines and breaks the 2D triangular structure, but it returns to the original shape after each movement is complete. Any movement that rearranges the points and lines while preserving the structure is called a collineation. There are 168 possible collineations, and they fall into 5 categories. The dual 3-cycle category includes the A and B moves on the puzzle. You can choose any fixed point and a line that's not connected to it, for example, point 2 and the circle, then rotate the remaining points and lines around them. Likewise, I could pick the circle and the center point instead and get this rotation. Another type of collineation has 1 fixed point, 1 swapped pair, and the rest of the points in a 4-cycle, like a quarter turn. The pair and fixed point are contained on 1 line, which acts as an axis. Repeating this collineation turns the 4-cycle into 2 swaps, like a half-turn or reflection, and restores the pair that was previously swapped. But as you can see, while the numbers on the original pair are now in the correct position, the colors are facing the wrong way. This is an unusual property for a twisty puzzle. The orientations of these pieces are tied to the permutations of the others. Repeating the dual swap collineation, of course, solves the puzzle, where all the numbers and colors are correctly positioned. The remaining collineations are 7 cycles, which are harder to understand because everything moves. For a complete list of collineations or to try the simulator yourself, check the links in the description. There were 2 big challenges in designing this puzzle. The first is that the geometry is really odd. It's an octahedron warped so that there's an extra vertex. To make it a viable puzzle mechanism, I curled each cutting plane by several degrees so they could all fit. The pieces don't move perfectly smoothly because of the irregular intersection angles. The other challenge was fitting all the gearing into the core. I came up with a way to combine a universal joint with a screw spring mechanism to implement the B axes, which spin in the same direction through the core. 4 gears are added to implement the A axes, which turn opposite each other. Visit my website in the description for more details, puzzles for sale, and online simulators. Thanks for watching.